Alright, so let me just start with the basics of any exponential graph. Do you know what that is? So if I
Um,
say it looks like that, I'm saying y equals, what's the thing they use? K, I think. K to the x. Do you recognize that kind of graph? Because that's important to understand what e to the x looks like.
yeah,
Yeah?
and
And what do we know about exponential graphs?
they never touch the x-axis.
Good. Okay, so the asymptote. Yeah, asymptote at x-axis. Let's write that. Okay, where does it always cross the y-axis?
One,
At 1. Good stuff. So that's the same. The same is true for e to the x. E to the x is just some funky number. Yeah, it's some horrible number, and you don't need to know too much about it. But do you know what the gradient is at this point here for e to the x that makes it special? Doesn't look like it on my thing, by the way, what the gradient should be like. Just gradient 1. That's the only
oh,
thing. There's nothing really special. Nobody really cares about it too much otherwise. It's just happened to be that. Anyway, so that's e to the x. Now, what do you know? Let me draw another e to the x because it's already got a bit messy with all the stuff there. I really want to do something. Okay, I suppose that makes it a bit easier. Um, so we got y equals e to the x. What's the relationship between this graph and y equals ln x?
it's been sort of reflected.
Exactly, in the y
Why?
equals
Yeah,
x,
yeah,
yeah? Or because y equals ln x is the inverse function, and any inverse function is reflected. So it's going to have the same asymptote, well, it's going to have a reflected asymptote. So instead of the x-axis, the y-axis is the asymptote. Now it
yeah.
crosses at 1 over there on the x-axis instead of the y-axis, blah blah blah. Nothing much more to it than that. I'm just trying to grab and stick over here. Yeah, so you said you were confused about it.
It's when
Um,
it comes to like exam questions.
okay, sure. I was quickly looking for exam questions, but I didn't quite see, so I just looked at the um, book. Actually, there are some here. What's this? No, no, maybe. Okay, I'm just gonna grab the hardest or the last question I can see from the book. What does it say? I'll summarize it for you. I haven't read it through properly yet. So you got fx equals 3x cubed. It does say ln at the end, so we'll come to that in a second. 4x squared minus 5x plus 2. What we got to do with that? Show that x plus 1 is a factor of fx. So far it looks nothing to do with ln x, but hopefully it will because it's got lots of lns coming up in it. So show that x plus 1 is factor of fx. So let's just see what happens. Maybe you'll do it. It's not such a bad thing to do. At least we'll practice all sorts of other stuff at the same time. So how do we know that x plus 1 is a factor of fx?
You do long division and then it'll come with the answer will be zero.
You could do long division, and what
Oh,
else?
but minus one into
Minus 1,
yeah,
so factor theorem, yep.
yeah,
Factor theorem, remainder theorem, basically the same thing, but yeah.
yeah,
So x equals minus 1 gives you, we're kind of expecting it to be 0, so 3 times minus 1, you get that, don't you? Minus 1 cubed is
yeah,
minus 1. Minus 4 times 1, minus 5 times minus 1 plus 2, so that's minus 3, minus 4, plus 5, plus 2, 7 minus 7 equals 0. Cool, so we proved it, whatever. So that's supposed to be part A. We're waiting still for the log thing to come up. Factorize. Oh, come on. It's saying factorize it completely, and there's still nothing to do with logs. Solve, giving you. I'm looking at part C actually. Part C is saying solve, giving your answers. Oh, okay. Giving your answers to two decimal places, the equation. Oh, probably should have picked a better one. It is half to do with. So it's got ln 2x cubed minus 4, and you can kind of see how it's linked to the previous thing, isn't it? Can you see that?
Yeah.
So 4, well, it had to be, isn't it? It's part of the same question. So ln 2x squared minus 5 ln 2x plus 2, wow, this is long, 8 equals 0, x is bigger than 0 is a little thing on the side, I haven't got space for that, forget that. Okay, just remember x is bigger than 0. Okay, so we might have to do part B where we factorize it completely, which is not such a bad thing to do, but it's not exactly the topic, but okay, so say we do factorize it completely, we're going to get these different values for what x could be. So we have x plus 1 is a factor, and we know that x equals minus 1 is one of the solutions, or the roots you might call it. And therefore you could say, instead of, because basically the x has been replaced with this whole long thing, you'd have an equation saying so that's great. We're going to skip part B, okay, and we're only going to get some of the solutions, yeah, because we really want to focus on this learn business. So one solution is x equals minus 1. There are also other solutions, x equals blah blah blah, but we haven't done part B, so we don't care anyway. We're not going to worry about those extra solutions for x. So basically what it boils down to is ln 2x equals minus 1. That's one of the solutions, isn't it? Does that make sense?
Yeah.
Okay, so I'm not sure if that's really what you wanted to do, because you were thinking about graphs sort of thing, but was that is this an issue? Is this hard to figure out?
Something similar.
Okay, you lead me in this one. Go on. What are we gonna do next? Hope you can't hear the tissue, me wiping my nose too loudly. Can you hear it though? Can you hear this?
Yeah, slightly.
I'll move it a little bit away. So, okay. A bit cold here, and gave me the little sniffles. Okay, go on. What do I do? Okay, so remember learn is a short way of saying log base e. Yeah, so it's basically saying that you could put a bracket, I suppose you should, equals minus 1. Okay, so what do we know about logs? What's another way of writing this log e 2x or whatever? Thinking e, purposely written a bit bigger, because I'm going to do something. E to the minus 1 equals
ln 2x.
Nope, just 2x. Yeah.
Oh, okay.
So that's it. You have to know your basics to really understand. So you don't have to memorize stuff too much, right? If I say, what's a good one? Log base 2 3. What is actually? So this will test your understanding of what I've just written. No, that's an 8. Sorry. Okay. So. Yeah, so what do you think log base 2 8 equals?
3.
3, good, so that's good. Okay, fine. So we get that, and yeah, so we say e to the minus 1 equals 2x. How are we going to work out what x is then?
Divide it by 2.
Yeah, that's it, just write half. Or if you wanted to, you could do stuff like 1 over 2e. Do you see what the link is?
Oh yeah.
Good. Yeah, because
If
it's like that, isn't it? And
yeah
it's timesing and whatever. Okay,
yeah
good. It's good to be able to do that kind of stuff because they love writing stuff in different ways to
yeah
see how good your algebra is. Okay, but was it to do with this kind of stuff, or was it to do with graphs that were putting you off? What kind of area of the log or natural log stuff, ln stuff, and the e stuff you didn't you like?
it was just there was this one question where it sort of you had to interpret the graph.
Interpret the graph. Yes, okay. I'm just thinking. I know what you're talking
It might
about.
have been
Is it the type that go
functions or
ae to the something?
it might have been yeah.
bx. Okay, yes, it could be functions. Um, okay, I'm just looking at the function section as well. Um, looking at something that's got an e to the x in it. Okay, let's just have a go at this other random one that I've just looked at. Function f is defined by, reading it as I'm writing, e to the x plus k, and k is a positive number, basically that, and state the range. What's the range of fx? So that is supposed to be part A. The range of fx. That's good. This is testing your understanding of what's happening. What's the range of fx?
Fx is greater than k.
Yeah, that's it. Very good. Cool. Part B. What's it saying? Find ln k. That's the f of ln k. That's a good one. Okay. So that is very good because that's reminding me of another important thing about, we kind of mentioned that they're inverse. You know when
Yeah.
you do an inverse of an inverse, what happens?
You go back to the original.
Yeah, exactly. So if I said, of inverse of x squared is square root. So
Yeah.
what does that equal?
X
X. Yeah,
squared.
exactly.
Oh,
So
it's
it's the original. So we know. But it's also got a plus k, and it's not a pure inverse, I suppose. So let's see. Ln k of fx. What does that mean? I mean, shall we write that in full? We know that fx means this thing here, e to the x plus k. So what is f of ln k? What does that mean? What's another way of writing that? So we're saying ln k replaces the x, isn't it? You know when you say fx means if I take input an x, out will come this stuff here.
oh, okay.
Yeah. So if I input a ln k, instead of the x, I'm putting a ln k. So I'm going to do e to the ln k
Yeah.
plus k. So what would that equal? Do you understand that? I replaced the
Yeah.
x with the ln
Yeah.
k? Cool. So, any ideas? E ln k. Okay, I'll give you a clue. You know we said x squared and then square rooted equals x. What about the other way around? If I do square root of x squared, what does that equal?
X.
Still, right? So you got two options for inverses with the e's. I'm just going to quickly put. So we could say e ln k, or even forget k, just like say y. It doesn't matter what it is, yeah. that, and what's the opposite? Ln of e? No, not ln e. I want to say, does that make sense? E to the y, yes, that's it. So, yeah. So what does... they're both doing the same thing, yeah? So that one equals y, and this one equals y. I'm trying to think, am I doing the right thing? I mean, I know it equals y, but they're inverses. So basically, this equals, guess what?
Oh,
Salaam?
you gone off the page.
Have I gone off the page? Ah, wait a second. Have you double clicked on the screen so you can see it full screen?
Uh,
You should double click right in the middle of the screen where you can, whatever you're watching, then it will make it full screen. Because that's what happens sometimes if people don't make it full screen. You can't see everything that's happening or something.
I've done it now, but it's still the same.
Okay, so let me just
Yeah,
point
now
us.
it's fine.
Oh, it's all fine, yeah? So what
Yeah.
we're looking at is this thing here. What does e to the ln k equal?
Um,
No? It's equal to k. Because e and ln are opposites. Inverses, I should say. No? You have to remember that they're just inverses. They look weird inverses because you're used to saying square root of x and x
oh, is
squared.
that one of the things that you have to remember? I think.
Yeah, you have to remember that ln and e to the
Oh,
whatever
okay.
are
Yeah, I think I remember.
opposites, so that's why that's how it works.
Okay,
Yeah.
yeah.
Okay. So yeah, so anyway, e to the ln k is k, and then you got plus k, and that equals 2k. Yeah?
Yeah.
Okay, so that's good. We covered some stuff about that. Still, I'm gonna keep going with this a little bit until we just finish this one question. Then we can do some vectors or whatever you feel like. Find f to the minus 1. Find f the inverse function of f. Obviously, that's the inverse. I'm reading it and I'm ignoring bits because it says find f to the minus 1, comma the inverse function of s, which we know is the inverse of the function of s. Hopefully, that means inverse function of s. And in the form f, well, that as well, of course, is like that. You can use different kind of notation, whatever. So you've got an arrow thingy. You could just say equals instead. Anyway, so in the form, x with. So basically, what they're trying to say in a very long way is work out. Oops, my X is getting really bad. But anyway, work that out basically. So what was f again? I lost it. F was all the way up there. Oh, e to the x plus k. Yeah, so let's just write that again. So we know that fx equals e to the x plus k. What is the inverse function of that? What was the trick for finding inverse functions? Do you remember?
Substitute it for y.
Yeah, so fx is kind of like your y, and you go, the original thing is y equals e to the x plus k, so what do you mean by substitute? What
Yeah,
do you
so
say? You say
yeah,
x.
what you've just done.
Yeah, except for have to do it the other way around because
Yeah,
this is the original, this
yeah.
one. Yeah. And so yeah, you got that. And then what do you do?
You make, well, in the other one you would make x the subject.
You make x the subject. Cool. So x minus k equals e to the y. Then what?
It'll be ln
Learn,
x
yes. So you
minus k.
learn both sides, and you get, or maybe, and this is not exactly what you were thinking, but I
Y-
kind of, yeah, go on.
Yeah, yeah,
You
that's
were
pretty much
good,
right. Yeah,
good, good. And some people might do extra shortcuts, yeah? They kind of go, oh, you're learning this e to the y, that means y straight away. But I try not to go, I don't know, you could go to that, or you could do it slightly longer way like this, making sure you understand. Do you know what I've just done there?
yeah, yeah,
Like, yeah, the y is a power, so it goes
yeah.
forwards. And what does learn e equal?
1.
1, so just cross it out because y times 1 is y. And anyway, you've done it. So basically, the inverse function, basically that is, what do you think it is actually?
Ln x minus k.
Yeah, cool. Okay, is there any more to this? On the same axes as part D, on the same axes, sketch the curves y equals fx and y equals inverse function of x. Giving the coordinates of all the points of the graph, cut the axes. Okay, I think you get this already. So you got, here's our quick axes. Might as well change colour for the different graphs. Okay, so you already said that basically the first graph y equals e to the x plus k, that is the asymptote there, yeah? Does that make
Yeah,
sense?
yeah,
And then we might as well, let's do a highlighter. There's our y equals x. Okay, that's your mirror line. Might as well draw that to help ourselves out. And actually, it said do a sketch, which means find out where the graph crosses the axes, as well as drawing asymptotes as part of a sketch. But what is that y-intercept going to be?
k.
K. This is K, isn't it? The asymptote
Yeah.
is K. Sorry?
K plus 1.
K plus 1, yeah. Okay, and it's quite easy to see that you know, the mirror line, it's quite hard. Maybe it's a little bit hard to see that. Whoops, let's rub that out. Learn x minus k would look like the way I've just drawn it.
Mm.
But given that it's a mirror line, it's in the mirror line, and it's got to have all the same kind of stuff. You know what I mean? We know
Yeah,
it's going to cross through there. It's going to have y equals k as the asymptote and stuff like that. Yeah.
yeah,
We could look at it in terms of transformations, because this is inside the function, right? Learn x, we know how it looks. I'm drawing really bad, Okay, learn x looks like, you know how it looks like.
yeah,
So if you minus k inside the function, that means go right k. So you could see it in that way, because originally it would have been like that, and it's gone right plus k. Do you know what I
yeah,
mean?
yeah,
But blah, that's going over the top, unnecessary. It's kind of good extra knowledge to confirm that you're doing the right stuff.
yeah,
Yeah. Now, you know what? You can always, if you find a question that you're uncomfortable with, like an exam question, just tell me,
yeah. Alright, yeah,
and look for it, make a note or something, keep it, and then even email it to me and we'll put it up. We'll have a go at it. You know what I mean?
yeah,
And if you got WhatsApp or something, you can send that to me. You can just, like
yeah,
one of my other students, to just take a picture of it and she just WhatsApps it to me, and then we just talk about it, and then I can put it from the WhatsApp. I can put it straight into my
mm,
onto the board anyway. So all that kind of stuff. So that's for future. Um,